Good evening, everyone. Welcome back to another session on retail analytics. In today's discussion, we will be discussing on unsupervised technique, that is k-means clustering. Okay. K-means clustering is also what we call as non-hierarchical clustering. Okay. In k-means, we have, that is, in non-clustering, non-hierarchical clustering, or segmentation, we have k-medians clustering, right? K-medioids clustering, as well as k-modes clustering. Okay. Most widely, k-means, that is, this clustering is preferred. Okay. If you consider a retail store, right? This particular store is a, let's say, it has a chain of stores dealing with gadgets. Or let us look at a retail store which is planning to launch a product. Okay. It has close to potential customers of throughout the location. Let's say north, east, west, and from the central region. Now it has decided to launch a product, and for that reason they have coming up with a promotion, and in that promotion they are marketing, they are sending out an email, right? Do they have to send that particular email to all their customers? Let's say they have close to 100,000 customers. Okay. Do they have to send the email to all these customers? No, right? In these customers, there might be someone who's a millionaire, right? There might be someone who is an international athlete, right? Someone who is working for a NGO, right? These are their existing customers. Do you think that if there is a launch of, let's say, they are dealing with these robust vacuum, right? Automatic vacuum cleaner. Do you think these customers, the elite ones, do they really care for these sort of promotions, or will they be looking for these products for themselves? No, right? They are, they are busy people. They don't need these emails, these promotions, or they might not be looking at this particular product, right? There's so much efforts that is going in the marketing promotional department that is not being served, right? So what they do is, for them, this promotion is irrelevant, right? You should be focusing on the customers who are willing or looking out for this particular product and their offers, right? And this is when the concept of clustering comes into picture. Okay. So what you do here is you will create different clusters or segments by using some kind of logic, right? So in one cluster, you will put all the, let's say, these athletes or politicians, the local ones. You can think of the local ones, right? Millionaires, right? All these you keep segmenting, and then you come up with a marketing strategy, right? The advertising strategy, where you're forming these clusters. They should be in such a way that there should be similarities between these clusters. That is, similarities within the clusters. Homogeneity. Right? So what are we doing here is, we are saying we are looking at these clusters, and the difference between different clusters will calculate by using between sum of squares. Okay. Now, if you look at what are these kind of clusters, you will find the distance between each data point. Okay, these clusters you have, let's say, let me put it this way. You have all these data points in XY plane. Right? Based on a logic, you are clustering. Right? and you will find the distance between each data point and the cluster center. Okay, that is your high density point. Okay. And these clusters are basically for your large data set. Okay. So now, if you look at k-means clustering and the application, it will have the performance. Okay, to put it this way, so you're with the help of k-means clustering, you are able to get the relevant data, right? And different models are being prepared, and you can also do the market segmentation, right? Market segmentation, retail segmentation, of course, customer segmentation, all sorts of these relevant segmentation you can come up with. Okay, and the number of clusters that are found from the data that you have is the k value, that is k in your k-mean. Okay, so first what you do is you need to come up with the number of clusters, and that clusters will be generated in your k-means algorithm, right? And based on that, you will categorize, that is, you just classify the data points, right, based on the centroids. Okay, and then we also look at the sum of squared distance between the data points and the centroids. That is done. After that, you look for each data point. You're allocating each data point to that particular cluster. That is, of course, which is closer to the centroid. Right? So this is again a k-means is, you can say it is the iterative formation. It is in an iterative form. Okay. So in other words, K means can identify the number of, that is number of centroids, and then it assigns each data point to a nearest cluster, while keeping the centroid as small as possible. All right. Of course, means, when you're saying means, it is the average. It is looking at the average. Okay. So here your centroids are stable, right? So we can consider K is equal to 2, K is equal to 3, right? If your clusters are 2, if your, if your predefined clusters, if they are to be created, you can start off with K is equal to 2, or K is equal to 3, and so on, so forth, right? Like I said, it is a iterative algorithm. And this particular unsupervised technique, it takes the data set as this unlabeled data set as input. Okay. So here the value of K should be predetermined. All right. We come up with a random, that is point, the K point, or centroid. Okay. And you assign each data point to their closest centroid, which will again form the predefined cluster. And now calculate the variance and place the new centroid. Okay. So you keep repeating this, that is assigning each data point to the closest centroid. Okay. And you keep doing this until the model is ready. Okay. You are basically reassigning each data point in a way. Right. At some point, we have to choose the K, that is K value at random. Right. And since we are finding the closest cluster, we repeat this step by choosing a new centroid. Right? All of this is going to be like a repetitive. You keep repeating these steps. Now, how do you choose the K value, that is number of clusters? Right? If you look at it, so let's say you are choosing the optimal number of clusters, right? And this has to be the value of K. Okay, one is the elbow method. Okay, so elbow method is one of the popular ways of choosing the number of clusters. Okay, and to measure the data between the data points and centroid, we can simply use Euclidean distance or Manhattan. These are the measures. Okay. So what it does is it executes the k-means clustering, and then we'll also look at the model. Okay, first is, even before you build the model, you do a data pre-processing. After your data pre-processing is done, you find the number of clusters. Okay, and this number of clusters you find with the help of elbow curve. Okay, and then of course you train the model, right? And what are the dependencies that you will be looking at? So we'll look at the dependencies as well. Pull up the Python interface. So here I'm doing after the pre-processing of data. Okay, I'm importing the dependency. Okay, I have pandas for my data manipulation. I'm importing pandas as PD. This is for data manipulation, as well as NumPy as NP. So NumPy is used for numeric calculation. Okay, and I'm defining a variable as data underscore class. So I want to load the data set that I have. Okay, and I want to load that in CSV format. So I will write pd dot read underscore CSV. Okay, I will quickly grab the data set and I will paste the location in the parentheses. So what you see is the location of this particular CSV file. This is my data set, and I have to replace the default backward slashes with forward slashes, or I can still go with the double backward slashes. So I will replace these with forward slashes. And also I have to mention the file name with the extension. What happens if I don't give the extension or the file number? See, just let me execute these. It will simply throw an error. See, it says permission denied. It is not able to look for a data set. Dot CS. Okay, so now I'm looking at these columns. Okay, I'm saying data underscore class dot columns. Let me first import these. So here I have these index, right? Now this is what I have. Now I'm importing another library and I will call for the info. I'm saying class.info. Okay, this is giving me the details. There are no null values. Okay. Once I have these, I want to look at the clusters. I'm dropping these objects. Let me drop these. Now, once I have those dropped, I want to look at the clusters. I'm saying data frame dot describe. Okay. And now if I, so here we are looking at the data set. Let me pull the data set. Okay. And I want to see the accuracy of this. Okay. The scores. Excuse me. Okay, you can also do these plots. Right. And then you want to split the data, train, and you're splitting split, train, and test. Okay. So you keep repeating, you manipulate with the k value and you want to know the variance. Okay. Okay, you can go with k is equal to 2, or you can consider the k value as 2, 3. It again depends, right? Let me run the so here if I have to look at So I have 50, that is 54. The frequency 1051. So based on your elbow curve, you get to decide on the number of clusters you want to pick. Okay. So remember guys, K-means is a unsupervised learning technique. Now let us look at one of its image. Okay. So here we are clustering these customers of these customers the non-returning customers or the visitation based on their visitation to a particular store. Okay. Segmenting. So these customers who we have in this store are of all age groups, right? And of course, professions, different professions, and genders. Right? However, their visitations have been increasing. There is no purchase records in their visit. Meaning the customers are able to, walk through the store's aisle. However, they are not making any kind of purchases. and we were able to cluster those customers, and with the help of this particular algorithm, we will be able to identify and segment those customers in specific groups and identify their preferences, preferences of products or the products that they are looking for. And once they are able to identify and group them in particular segment, so what happens is the retail business will be able to service the customer better by having them stocked, right? So if you, let's say, if you stock up the products, they will be able to understand which products are in deficit, right? That will also help him in the inventory management. And there is a chance that these potential customers will be the regular ones, right? So we have looked at, so with K means we will be able to look into within sum of squares and the between sum of squares measures on the clusters, right? As we said, we are looking at a large data set from across the retail stores across that particular location or the town in which they have placed. That is the retail store, right? So, like I said, once they are able to identify the needs, that is preferences. For example, let's say this particular customer who is a college going kid is looking for a sports gear, okay, or a kid is walking in. However, he is not able to find a particular product even on multiple visits. So he is very less likely to purchase any product because he is looking for a specific product, correct? So that is the reason we will be able to help with these clusters and serve the customers better, these retail business. Okay. Of course, this clustering can be applied in different department of the retail industry as well, not just in the front line of the store. Okay, it can also be applied in the fraud that the customers are committing when they visit a store, right? There could be a difference in the billing or the stock, basically the inventory, right? At a high level, we are looking at this at a high level, right? Clustering can also be applied in those scenarios. All right. Okay. All right, friends. We will stop our discussion here for the day and continue in our next session. Thank you all for joining. You all have a good day.